two-sided arrow like this, we just put a solid line like this. This is bidirectional. That means I can have class A associated with class B, class B also associated with class A. Okay? It also can be unidirectional. That means it is one way only. That means class A is actually associated with class B, but class B is not associated with class A. So it can be bidirectional or unidirectional, but it depends on your program, how you want to do. Okay, not necessarily it must be bidirectional. It must be unidirectional. And even unidirectional or bidirectional also, they can have multiplicity. That means 0 to many, let's say. 1 to many, you can specify. Okay, so example, if you want to specify, so example, maybe this is 1 to many. This is 0 to many. So you can specify the cardinality. In ER diagram we call it as a cardinality. But in a class diagram we call it multiplicity. Okay, multiple time or what. Okay. Or 1, 2, let's say 0. You now no need to put 0. Let's make it is 0. So you can specify. Okay, so this is association. I think association should be no problem, right? Okay, association should be no problem. So let's see some example here. We can see here, student taught by teacher. Teacher maybe taught student. When it is a solid line like this, that means we can say that it can be two ways, bidirectional, right? So 1 to many students teach by one teacher, and one teacher can teach 1 to many students. Okay, so maybe this is easy to read. Or you want to do something like this also can. Maybe one particular association here, it cannot fit for both. You can do like this. Person work in a company, company hire person. Like that also can. Okay. So 1 to many person can work in one company. One company can have 1 to many person. Okay. So this is the way how we can read. Or sometimes you can see something like this also. We'll have an arrow like this. So that we will know that we have to read like this. Okay. Customer places order. We cannot read like this, right? Order places customer, right? Okay. But when you see this one solid line, it can be two ways also. Okay. But the association is like reading like this. Customer places order. Okay. So like this arrow also you can put to indicate read like this. Okay. And this one unary relationship, that means the class is point to itself. Okay. Which is in this example, a person can be a worker and a person also can be a manager. So manager, 0 to many manager supervise many person. Okay, we can read like this. And driver and also car, this one got no relationship. Okay, sometimes they will do have something like this. So as I told you just now, if you have a relationship, it's easier to recognize or understand. Okay, so we can say car is driven by a driver. Driver drive car, like can, right? So maybe drive. You can put drive, also can. But this one easy to recognize, so should be no problem. So this is how association is look like. So when you have association, how we will code it? Okay, I say I will show how we want to do a coding, right? So example, if you see, we say that, let's say in this example, I just want to have unidirectional. That means student taught by teacher. So maybe I want to see this student is taught by which teacher. Okay. So if I want to identify this one, I will include this one as one of the data view inside the student. Okay. So I'll show you one example. this example. I have a department and also I have employee. Employee work in a department. Okay, so it can be association, right? Okay, employee work in a department. Works, okay. So I created employee class. Employee have a name when we have a constructor and just want to display the name. Okay, and we say here department want to have department, I have a department name. Okay, even you don't have as a data field, I actually can do something like this. I go and create one department, one employee. I also can display like this, right? This employee work in this department. Can, right? Can also, right? Can? Okay, can. Like this also can. Okay. Example 2. Okay. I want to have something like this. I want to have a student and I want to have a course. Okay. Student take course. Okay. So student take course means it can be one student can take many courses, right? Okay. So one student can take many courses. So I want to know what courses the student actually take. So one example is I create a course. That means I have a name. Okay, just get the name. And I go to the student. We can actually associate the course inside the student. That means we say that I want to identify this student take what course. Okay, and the student can take many courses, right? So I can create as an array. So if it is more than one, it's supposed to be an array. Okay, so it must be an array of courses. And the previous example is just one-to-one. Okay, so I want to have array of courses. So similar like how you are initializing the data view, we do the same thing also. Okay, we do the same thing, which is I want to create the courses maximum, let's say 5. Okay, you do exactly similar like how we will be doing normal. Okay, so maybe enroll course, student can enroll course. Okay, I want to specify what is the length assigned to that particular course. After that, I want to display which particular course that the student take. Okay, because when you have courses here, you can call all the methods from the courses, right? From the class. Okay, from the student, you actually can call the methods. So I can display all the courses and everything. So this is how to do association. So if you want to do association, you just bring the data view that's means object as a data view in another object. Okay, that is how we will be doing implementation. But even if you don't want, you want to do a simple program like just now, like employee in which department, something like that also can, no problem. Okay. So this is association. So I think association should be no problem. Example, if you see here, we have driver drive car. So one driver actually can drive many cars, right? So since many car, so car will be an array inside the driver. Okay? And we also want to have, this is 2 ways, right? So this car is driven by which driver? Since it's only one driver can drive, so I will have driver, no array. Okay, so if more mean here will be array. Okay. So association, I think it should be no problem. Okay. Aggregation. So but relationship also, it can be a specific type of relationship, a stronger form of relationship, okay, which is we call as maybe it is has a relationship or maybe as a part of relationship. So if it is a has a relationship or a part of relationship, we go for aggregation or composition, okay, because relationship it can be any type, right? But I want to specifically say that this particular object has that, okay, has it, okay, because will be a part of that particular object. Okay, so it will be a stronger form of association. We go for aggregation. But one class represents the whole, which is a parent. Another one will be the component, which is child. So example, if you see here, aggregation, we will be representing using diamond shape like this. And how do we want to read? Class A has class B. Okay, association just now, even we don't have this as a data field here, also it still can work. Okay, but when this is the relationship, if you already mentioned class A has class B, so it definitely must have as a data field in your class A. So this is some example. Okay, college has teacher, college has student. Okay, department has teacher. So since department is the one has a teacher, so teacher will be one of the data field here, and one department can have many teachers, right? So here it will be array, collection. List also a collection. Array list also can. It is a collection because we have more than one value. Okay. So anything, list also can, array also can, array list also can. Okay. So that is how we specify. Example, if you see, company has department. One company can have one to many department. Why we say that this is not association? Because association means it is not strong relationship yet, right? But this is a strong because we say that company has department. Because in a company, department is one part of it. One part of it. Okay, so when we creating a company, we will be creating a department also. So it's a stronger form. So bus driver, let's say bus driver has clothes, bus driver had hats. So clothes automatically will be one of the data field. Hat automatically will be one of the data field because we say it has it. So it will be one of the data field. Okay, and we can't have something like this. Two sides also have a diamond shape like this. Okay, a single association represents particular relationship between instances. Okay, same object cannot be simultaneously a part of another object. At the same time, class B cannot has in a class A, and class A cannot be in a class B. Okay, but association can, because they are associated. They have both. They have some relationship. But this one, you say that class A has class B. But we cannot say class B also has class A. Cannot. It must be one way only. So usually it must be one-sided only like this. Diamond shape. Cannot have a both side like this. Okay. So or usually the relationship also you can indicate. Okay. 0 to many classes can have. 0 to many. So you usually here is we read like this. One class have how many objects? So usually here is not going to have a many. This class has this one, maybe this one time or many times. Okay, usually here not going to have many or something like that. So that's why usually when you see diamond shape, they never put any cardinality here. Only this side they will have the cardinality or multiplicity. Okay. So this is association, aggregation. Okay, aggregation. Okay. Now we see the sample code. Aggregation, if you see, I have a student and also address. Can I say student and also address is aggregation? Some maybe they will say that it is a composition. It can be a composition also. All is depend on your assumption. I say that this address, I know that one person only can stay in one address. If this particular person don't have that address is no more, it can also. But I also can assume one person staying in a condo, that condo particular house is actually shared by multiple students. I also can say like that. Okay, depend on your context. So in this example, I want to do student and also address aggregation. One address actually can share by multiple students. Okay. So since we say student has an address, I will bring my address as an object or data view, address object as a data view into the student. Okay. So when we are initializing, we will be initializing like this, return all the information. Okay. When I want to create, I will create address object, I will create student, and here must be address object, right? I will put my address object inside here. So I will know that this student is staying in this address. Can, right? Okay. So this is the way how we are doing aggregation. But remember, aggregation is a little weak relationship. If compared to association, this is stronger. But if you compare with composition, aggregation is a weak relationship. Why we say so? Let's say this is a parent, this is the child. If a parent does not exist, child still can exist. Like address just now, let's say I created one student as one. Example like this code. I created one student, I also created one address. Let's say I remove this student. Okay, this address can be standalone or not. It still can be there, right? I can associate this address to another student, correct? Okay, and another one in the code. Let's see in a memory diagram how this one is actually works. Why we say that parent destroyed me, child can be exist or something like that. Okay, drawing was not that aggregation. Okay. Let's say I have a driver and also car. Okay. Driver and car, is it aggregation? Driver can drive car. Driver has a car. Can? Driver has a car. Okay. So I want to have a driver has a car. Even you want to put driver drive car also can. That's mean association also can. Okay. Now in this example, I want to say driver has a car. So I want to see, since here is a car, is just one object. That means one driver only have one car. Okay. So this one is aggregation in my example. Let's say I have a driver class and car class just having a model. I ignore all these methods. Okay. Driver, I will have a name and also an age, and I will have car C, correct? We will have this as a reference here, right? Okay, so this is what we already know. Earlier, we already learned if any object is referred, then it will be exist in the memory. If there is no references pointing to the memory location, it will be garbage collected, right? Automatically. Some references must point to the memory location. If not, it will be garbage collected, correct? Because no one pointing to it. No one referring to it, correct? Okay. So let's say I'm creating class task. Wait, I open this one. Shh. Smart student behind. Yeah. Okay, so let's say I have a driver program. I created a driver D equal to new driver. We already learned it is a creating an object, correct? So it will be created under the heap memory. This is the class name, okay? This is the address, right? Address. Address will be in hexadecimal. I simply put some hexadecimal code or something, okay? So this D will have a memory location of where this particular object is created, right? Okay. So first when I didn't do this code, I didn't write this code, name automatically will be null, correct? Because it will take a default value, correct? age will be 0 because it will take a default value, correct? And C also will be now because it is not referred anything, right? Object. Okay. Now let's say I assign d.name equal to Ali. So null already become having a memory location to the string called Ali, right? Okay. Age I put 50. Age also will be 50. But C still null because I haven't assigned anything. Okay. Now what I will do is I will go and create car object. When I create a car object, it will create a car object. This is the car object. Let's say this is the memory location. Okay. Then I put d.c equal to C1. Correct, right? This is the way how we will do, right? This dot address equal to address just now. So d.c equal to C1. What will happen is, that means this C will have a memory location of car at this particular memory address. Correct? Correct or not? Car will have memory location of this one. Correct or not? Correct? Okay. Now I do d equal to now. That's mean d equal to now mean this one no more, right? Correct? So this one will be garbage collected. Correct or not? This one will be garbage collected. Correct? This one still will exist or not? C1 is actually referring to this one, correct? This dot C equal to C1 is actually referring to this one, correct? That means there are two references pointing to the memory location. So when I actually destroy this now, that means this one is dereferred. But this one still exists, right? Exists or not? This one still exists? Correct or not? Only this one is dereferred. This one is actually removed. But here got two pointers, right? One is this one, another one is this one. Both are pointing to the same memory location. But this one is destroyed, means this still can exist because this one pointing to this. Correct or not? Correct? That is we call as aggregation. If a parent is actually removed, child still can exist. This is why they say that aggregation is parent is removed to be child still can exist. This child actually we can associate with another particular object and later we will create also. Okay, that's what we say parent removed to mean child still can exist. Okay. Okay. That is aggregation. So remember, as aggregation has a relationship. Whenever I think that it is actually more to has. Okay. And if a parent removed to mean child still can exist. Okay. And lifetime of the child and parent are different. Their lifetime is different. Life cycle of these particular two classes are actually different. This one have its own lifetime. This one also have its own lifetime. They are not type. Okay. So if like that means go for aggregation. Okay. Next we have composition. Okay. This is even stronger form of aggregation, but it still has a relationship, but implying that part is a critical component of the whole. That's mean in order to do this one, we need to have this. This class cannot exist. This one is a part of this one. Okay? This one cannot be independently exist. It must be associated with something. Like addresses can be independently with that. We can associate with another class. But this is very tightly related to this one. So this one is one part of this. So the life cycle of this one and of this one is the same. Their life cycle. If this one is destroyed, this one also will be removed. Okay. If the whole is deleted, the part also deleted as well. So association, this one we call belong to association also. That means one class is essentially a member of another and thus exists due to the relationship. Okay, it is a member. Okay, so their life cycle are very tight. How we define in a class diagram? Still the diamond shape, but we will fill it. Okay, we will fill. Example, let's say human has a head, human has a body. This head cannot be independent like this, right? Okay, body also cannot be independent. So head and body is a part of human. Okay, and still the same, we will have this one as a references to this, and we also will have this one as a references in this. That's mean data view. Okay, let's say I say library has books. Can the books be like that without a library? Library is exist, then only I can put the book inside. Okay. School has a classroom. There's no classroom. School, yes, classroom cannot be independent like that. It must be inside a school, right? Okay, so it's, the life cycle of these two are tied together. Okay. And why we say this one, if the parent is removed, child also will remove. We see some example of code first. Okay, try to see the differences between the aggregation and also composition when you doing the code. Okay, I have a job and also I have a person. Let's assume that the person is, the job is belong to a person. Okay, that means the job will be created when the person is there. Okay, so I say that person has a job, so I will have job, okay, as a data field. But can you see object creation of the associated class will be created in the constructor? That means when you created this particular object, your associated object also will be created at the same time. When you create person, P1 equal to new person, job also will be created, right? Both objects will be created at the same time. That's why we say that the life cycle of both are actually dependent. Both are tied together. Okay, both will be created at the same time. Okay, this is a simple example. We go for another example. Okay, let's say I have author and also books. Okay, books can have many authors. Okay, authors, actually books mean author is a part of the book, right? Okay, without author the books cannot be published, correct? So I say that this is a composition, and since one book can have many author, so I will have maybe array or maybe list or array list of the author. Okay, since this, it is not logic if I put array, because I cannot fix the size, right? How many authors? Okay, so if we use a list or array list, if you want to dynamically resize. Okay, so this one is example, author equal to new array list. This one you might be using, we are not covering in this course, but when you are taking data structure and algorithm, I think maybe next year. Okay, data structure and algorithm, you will learn about this one. This one is generic. What is that generic? Okay, this one is, even you want to put like this also can. That's mean I want author. Okay, that's mean you can create array list, you can store integers, you can store strings, you can store object and everything, right? So you can put a triangle shape like this to indicate what type of array list is this. One array list, but you can store multiple type of data types, right? So you can specify what data type is this array list. This array list store author objects. Since I already defined this author, I don't need to redefine again here. Okay? So object creation is already declared here. We already created. Then we can do exactly similar like how we will be doing also. We get author, we add authors and everything we display. But the differences is aggregation and composition. If you see, composition, the object creation will be under the constructor. Okay? But for the aggregation, we are not creating the object there. Okay? That is the differences. In some references, if you see, they will try to put the code, but code also is like the same. Okay? But initially, if you want to design composition, this is the way how to create a composition. Okay? And if we want to see the diagram again means, let's see composition. I think this one. Okay, yeah. Composition. Okay, let's say I have a human and also hard. Okay, I have another class which is class hard. H. Okay. Human has a heart, correct? Heart cannot be independent. So let's say I have a string name Ali and we have to create a heart here, right? Heart H equal to new heart. Okay. So let's say in a test class, I'm creating human, okay? So in the heap memory, can I say that it will create an object called human, which is have a memory location, name equal to Ali, okay? And it already created the heart, right? Okay? So it will create another object. That means there will be another object, which is a heart object, right? And this HT, this is human. This is HT. Okay. So this HT equal to, it will have memory location of this one, correct? Okay. Now if I put H equal to now, this one is destroyed or this one is de-referred. This one also will go on together, right? Because there's no other references to this one. But if you compare with just now, C1 still pointing to this. D.C is the one pointing to this one. Got two references, right? But this one is only one reference. So this one is removed, mean this one also will be removed. That's why we say the life cycle are actually timed. Of course, the design if you put create an object is a constructor, definitely are tied together, right? Okay, that's why we say composition parent is removed, child also will be removed. Okay, the design is like that. So in some example, as I told you, maybe the code is similar like aggregation. You can't see the differences. Okay, but actual implementation supposed to be like this. The object creation should be under the constructor of the parent. Okay. So aggregation and composition is also same. We will be creating a data field as an object in the parent class, but the creation of the object will be under the constructor in the parent for the composition. Okay. And is how we want to differentiate, try to check both have same life cycle or not. Okay. Another example, if you see, between order, product and line item means order detail. Okay. Order detail, order and also product. Okay. Let's say I have product. I think this one we referred last week. Okay. I have order, I have line item. Okay. What is the relationship between all this? Order and order item. Can right? Order will have line by line the item, right? Apple, how many quantity? orange, how many quantity? Line by line, right? Because you can have multiple orders. So can I say order has line item? Has a? Has. So it's a diamond shape. Is it composition or aggregation? Aggregation or composition? Try to check. Is it the life cycle of order and line item is the same? If the order deleted, the line item have to be deleted or not? Or this one can be independent. It can be shared to another order. I created one order 1 equal to new order. Then I have order 1 have the detail, what is the item and everything. Let's say this order 1 is removed. This one, can I put into another order 2 let's say? No, right? It did not share. That's mean order, when you create order, you will have order items. So this is actually a composition. Okay. Product and which one? Order has product? Or line item has product? Line item, right? Okay. Line item, one line item can have multiple products, right? You want to make it this one association also can. Maybe you say contains, okay, like that also can. Or you want to say line items has product, like that also can. Because both implementation will be just same as a data field, okay? So is it composition or aggregation? Composition or aggregation? Line item means, let's say apple, one quantity, price is 2 ringgit 50 cent. Okay, this apple is the product here. So if a line item is removed, product also have to be removed. I created one line item, then I put a product inside this one. Product we have apple, quantity and price. So if a line item removed, product have to be removed or not? No need, right? This product can be go for another list also can have apple 1, 2 ringgit 50 cent like that, right? Can, right? It is shareable. This is shared, right? Okay, so it can be aggregation. Okay, even you want to put association also can. So that is how you identify. So in this example, if you see, we say that order will have order line, right? So I have a line item. This is a line item. Okay? And we say line item will have product. If you see here, we just assign like this only. We didn't create a new object. Okay? That is the difference. I'll put this code all later. This code and also this Word document. Okay? So this one is a composition. So aggregation, composition done. We also have inheritance. Inheritance actually very easy to understand. Okay? Categorization. You just remember or categorization or generalization. One general name and specific. Okay? So, example, if you see, I specify person is general. This person, it can be more specialized, which is, this one also we call generalization, specialization. Okay? Which is, person is general. If you go more specialized, mean it can be employee and customer. How we read? Employee is a person, customer is a person. Okay, this is how we read. Document. Document is general. Document also, it can be a book or it can be an email. Email also document, right? Book also document. Magazine also a document. Okay? So book is a document, email is a document. This is general, this is more specialized. Okay? Bank account, saving account, current account. Okay? Student, postgraduate, undergraduate. General, this is more specialized. Okay? Something like that. And we actually haven't learned about abstract class and also abstract method. We will learn in the chapter 7. But now when you draw the class diagram, you can draw first. But sometimes when you see some example, maybe the class is italic. The method also italic. If the method or the class is italic, that means it is abstract class or abstract method. Okay? So later part we will cover. So don't confuse them. Okay? So that is an inheritance. We just use triangle. Okay? In some example, they will shade it also, shaded triangle. But shaded triangle, sometimes they use for association as well. Okay? So can't see the difference. But usually in many examples, they will use a triangle. Okay? Without shade. Different tools and different rules. Okay? Like person can have a student and teacher. But why we want to do like this? Why we want to show relationship like this? Because this is general. General means it is open for everyone, right? Specialization means specifically what is unique about it. So, whenever you try to identify that this is general and this is more specific, general, let's say person will have a name, age, size, hair color, let's say. That means student also will have this one, right? Teachers will have this one also, right? Because this is general for everyone. So whatever general between these, you put under here. Method also you put whatever general under here. More specific what this one have, you put under here. Teacher, more specific one, put under here. So you no need to repeat this one and also this one in the student and also teacher. You can reuse. Reuse. You can call. You can call. You can call. Okay? Same goes payment. Payment can be a cash, check or credit. It's an inheritance, right? Specialization. This is more special, this is general. All type of payment. More specific you go mean it can be touch and go, credit card or debit card and everything. So it is also inheritance. Amount, everyone also have amount. But check will have bank ID, cash don't have. Each different, uniquely different. But generally all will have amount. Okay? We will learn this one in chapter 6, but example. Inheritance, how we specify inheritance? I have a person and also student, let's say. Student is a person, right? So we will be using the keyword extends person. Automatically, you can call CGPA is actually from person. Name and address is actually from the person. Okay? So student, if you see, this one on don't worry yet, okay? This one on don't worry yet. So let's say I created a student class S1 dot student. This one don't have anything. Name private, okay? Remove this one. Put one get method. Let's say I put one get method. Get address. Okay? In a person, I have a get address. Can you see get address? Even though the get address is not belong to the student, but it can access to the get student, correct? I tried to remove this one. Cannot find get address. That is the keyword. Okay? So this one is actually inheritance. Okay? inheritance. This is very easy to understand. Okay. And you also will see that a dashed line, not a solid line. Previously, if you see solid line with a triangle, we say it is inheritance, right? Now this is dashed line with a triangle. This one is realizations or implementation. This one is used, this one also we will cover, is interface. When you create interface, interface here is not GUI, eh? No, not GUI. It's a concept in OO also. We will learn, but many of you trying to refer some references and everything, try to do your class diagram, right? So I just want to show you some notations and everything so that you can understand when you are doing. What is the purpose of this interface? You can have some uncommon classes. Okay, we know person mean we can have a student and also teacher. We know these two are actually a person. Okay, we share all the method. Where share all the method? Let's say I have a person, then I want to have living things. Let's say living things. Okay, I can break it to animal and also human, correct? But let's say I want to have a cupboard and also human. How I want to categorize this one into one same category? Living things? No. Non-living things? No. Can or not? Can I categorize this one under one generalization? Cupboard and also human? Cannot. Cannot, right? But I know cupboard also we can make it move. Human also can move. Both have something common. So, that time we can go for interface. Okay? So this one also like an inheritance, but when you have uncommon, not common classes, but somehow they can be related. Okay? So interface will have dash like this. Okay? We will learn, don't worry. And lastly, you also can see enumeration. If you use a C or C plus struct. Okay? So UML enumeration actually represented a complete list of all value for a given type. You might have some predefined value. Let's say order status. I have 4 order status. Process, ship, pending, okay, shipping or something like that. I have 4 status. None other than this status. So how we want to specify in a UML class diagram? Okay, we can do something like this. Okay, which is you can do a dash line like this, dashed, and like this, in order to specify car uses brand. Car have a brand. Okay, actually this one similar like a data type. Okay. Brand here is actually brand. You call this enumeration. I have all this. So this car can have this type only. Okay? Or you don't want this one, the relationship we call uses. Use. Okay? Or sometimes it is not a use relationship also. You want to create association. Like this also can. Paragraph can have text alignment. That text alignment can only have these 4 options only. You want to do like this also can. Or you don't want to create anything, just leave it like this also can. Beside that particular class, you just leave it like this, enumeration. Example, if you see, this is frequency. Frequency, we know have to refer to this one. Frequency means this is the set of value. Let's say web user, they have a state which is user state, which is I have new active block and ban. You just create like this. You don't want to create any relationship like this also can, optional. Okay? If you think that it is has, then you can create like this. Or if it is uses that one, then you do the uses like this. Okay? like this. Car, I have a model and also brand. Okay, similar. Okay, get brand and everything. I will create one Enam brand. Okay, Toyota, Honda, let's say whatever car that you want to have and everything. So when I want to create my car, I no need to type any value here. Toyota in this one in this one, because maybe they will type different value. Correct? Okay. So I can call brand dot Toyota. This means it's a Toyota. These are the value that I want to fix. Option that available. Okay. So you get the model and brand mean it can display the brand. So this is enumeration. Okay. And lastly, this is what we saw just now, right? Here. This one. That one we call dependency. Depend. Okay. Example. Report generator actually depend on formatter in order to format the look and everything, right? Or maybe I have a calendar class. Calendar class actually is using the date. So, it depend on this one. Okay? So, car also actually uses oil. It depend on this. Dependency uses. This one is use. So, but when you are doing implementation, this one will become parameter in your method. Okay, example, if you see dependency, car has a car and engine. Car uses engine. Okay, so I have an engine type. Okay, this is just normal. Then go here, install engine, parameter inside. Okay, dependency. No need to worry about this one. You concentrate about association, aggregation, composition, inheritance. Okay? But some will say that best practices is try to do association. Okay? So, but depend. When you has the class diagram is look like we know how actually to read. Okay? We know that stronger relationship or it's a weaker relationship and so on. Okay? So that is a class diagram. Actually, they cover a lot also. They have constraint also you can set in the class diagram and so on. Okay? We cover just basic stuff. Okay? Let's again try to compare aggregation and also composition. This is weak. This is strong. Okay? Class can exist independently without the owner. Owner removed, since a child still can exist. This one is both are tightly coupled. One doesn't exist, another one cannot. Both have different timeline of the owner and also the child is actually dependent. A uses B. This one is A owns B. Own is own it. Okay. Child is not owned by one owner, but it can be shared. Child can have only one owner. Okay, that heart is belong to that human only. Okay, it's an as per relationship. A has B. It's a part of relationship. B is a part of A. If that B doesn't exist, A is not complete. Okay. This one next time when we learn final keyword. Okay. Field diamond. Okay. Mobile has a SIM card. Text editor uses a file. Company and also people. Human and heart. Company has account. Okay. All this one as an example. Okay. Okay or not? Can. Can we try one example? Try to check this one. This one is last year exam paper. Try to check this. In a university, there are different classroom, offices and departments. One way how to identify whether it is a class or not, try to look for noun. Objects are actually noun. In this example, which one are noun? Yes, classroom, offices and also department. So try to underline. A department has a name and it contains many offices. When you read this one, you already know. Department must have office. Department has many offices, right? Is it composition, aggregation? If this department doesn't exist, this office cannot exist. Can, right? This office can associate it with another department. Okay? And offices, okay, remember this. Offices and classroom have a number ID and classroom has several seats. What you can understand from here? There is some hints from, can identify something. Offices and classroom have a number ID. Classroom has several seats. What relationship that you can identify? Inheritance, correct. Okay. Inheritance. Offices and classroom. Just now we already identified this is one, this is one, this is one. Offices and classroom have a number ID. That means these two actually is a part of something. Specialization. Both have number ID, right? So must have some parent for this one. We can share. But classroom, they have its own, which is seat. So here we can see one. Let's say I put room. Room means it can be classroom and also it can be office. Okay. Can be like this, which is number ID I can put here. Under the classroom I put seat because classroom only have a seat. Okay. And a person working at a university has a unique ID and can be professor or an employee. What relationship? Yes, this is inheritance. All of them work in an office have a bank account number. Office just now we already identified bank account. Okay. So all the person who are working in an office, they can have a bank account. So bank account and office, what is the relationship? Composition? That's mean all the person who are working mean all the employees, right? Employee can have a bank account. So employee has a bank account. Can? But it's aggregation or composition? Composition, aggregation. Bank account. Is it shareable? Lifetime of this is tight? Is it own it? Employee actually own that particular bank account? Correct? Composition? Okay. A professor can be full professor, associate professor. And he is enrolled to one department. Here you can see inheritance, right? Okay. So, first step, when you have something like this, you try to identify all the nouns. Okay. Even university also a noun. Okay. So try to identify noun. After that, you check what is the relationship between this. After that, identify whether association or aggregation or composition. So in this one, if you come out, it can be something like this. University has a department and also has a room. Office, department has an office. And just now we said room actually have a number ID, right? So we can have this one as a inheritance. Office is a room, classroom is a room. And person actually work in office. And everyone will have account number. So I don't need to put professor have account number, employee have account number, person. I can put under the person. That's mean either it's a professor or employee also, they both can have a bank account. So person has a bank account. And professor can be any of this type. This is inheritance. Okay? And person also can be employee or professor. I think this one we already identified, this one already identified, this one already identified. Okay? And university, they say have a department and room, right? Go line by line mean you can identify. Okay? So this is one example of the class diagram. How we can come up with the class diagram. One department can have one to many offices. Usually here will be one or two. Okay. Okay, this is how we can do. Okay, there's something that I have to cover in part B, slide 22. Okay, one more thing. Previously we learned about static variable and also instant variable, right? Okay. Sometime when you create your program, it will tell you some error message like this. Non-static variable cannot be defined in the static content or something like that. Maybe you have experienced that error message. Right? Okay. Why that one is happen? Static variables and also method can be used from instant or static method in the class. If you have static variable or you have static method, you can call this static variable from instant method. Okay, you can use static is actually very open-minded. But if you have instant variable and also method, can only be used in instant method, not in the static method. If you have a static method, you can't call instant method inside or instant variable inside. Okay? Example. Okay? If you see, this is my class. I have one static variable. I can have one instant variable. This is static method, right? So, can I call this one instant variable? This is static method. Can I call instant variable? Cannot. So, maybe you encounter this type of error. Non-static variable. So this is the problem, okay? Because by nature, static variable, static method cannot have instant variable or instant method inside, okay? But instant method, they can have both static and also instant together, okay? So no problem. So static is like that. That's why in the main method, usually when you have something like this, it will give this problem. Okay, main method is a static method one. So you cannot have the instant variable inside. Okay. This is one. this. We already learned about modifiers, right? Modifiers, which is we already learned about private, default, and also public. We leave the protected for a while. Chapter 6, we will learn more about protected. Okay? So let's say I have a package. Okay? Let's say I have a package P1. Inside package, I have these two classes. Inside package P2, I have these classes. This is package P1, this is package P2. Okay? C1 class, this is how it looks like. C2 cannot access O.Z. O is one object that created from the C1. So C1 O.Z. Z mean which one? Z. Here, correct? Cannot access to Z. Why? Because this is private. Correct? Correct or not? So this one done. Cannot invoke O.M3. M3 is this one. Definitely cannot because this is a private, right? Okay? So this one, okay. Now we go to another package. Cannot access O.Y. O is instant from C1. Cannot access O.Y. This is Y. Y cannot access. You can see, right? Not clear. Not clear? Clear?
No.
No. The writing is not clear. Writing is look like clear. Okay. O.Y can access or not? Why? Yes. When you never define the access modifier, that means it is a default. Can be accessed within the package only. So this one cannot access. Okay. Cannot access O.Z. Z definitely cannot, because this is a private. Okay. O.M2. M2, this one. Cannot because it is a default, right? Okay, cannot access. Cannot access O.M3. Definitely M3 because it is a private, right? Okay, cannot. Now I have class C1, class C2. Can access C1. Can or not? Can, because this is default. Same package can access. Now, cannot access C1. Definitely because this is default. Same package only can access, right? But can access C2. Why? Because it is a public. Okay? So this is the access modifiers. Okay? An object cannot access its private members. If you see here, this is test class, this is X. So foo.x cannot because it's a private, right? As shown in B. It is okay, however, if the object is declared in its own class as shown in A. That's mean here they declare it. Okay? Can. This is definitely private, can be accessed within the class. Okay? So this one also done. Actually, we already covered all the chapter 4. And because most of the slide is repeating back and everything. So I try to use the code and everything to explain. So if you go to the summary, okay, chapter 4. Chapter 4, once you already learned, that's mean until today, what you have to have is, if any question is given, you know how to create classes. Okay, you can identify how many objects involved. You can create the relationship, and after that you can code it, similar like how you did the practical for part A, the registration. car type and everything. Okay? So should be able to do something like that. So if you're able to do something like that, you are on track. Okay? So we cover back all the chapter 4 again. Then next week we will be going for chapter 5. So we already learned previously, OO have encapsulation, inheritance and polymorphism. What is that encapsulation? Encapsulation inside have data hiding. Okay, so encapsulation itself, if you see, both the data and also code that operate the data you put into a single unit, which is we call as a class, we call as encapsulation. Okay, so when you encapsulate, then only we can apply data hiding, which is you make the data field as a private and provide public accessor and also setter method. Okay, so we already learned about encapsulation. Okay, so it binds together the code and also data it is manipulated. So we can say that in a way that we want to have a self-contained box. Okay, if you compare with the procedure programming, data is separated, method actually separated. Okay. And we also have class abstraction. Previously in chapter 2, we learned about method abstraction. What is that method abstraction? Which is, we are actually will develop a method. The implementation is actually hidden from the user. User just have to know how to use it, right? Similar like the scanner class. Scanner class, we know that next int, next float, next double are method. But do you know how it is implemented? No. So it's a method abstraction. We say that the method implementation is hidden from those going to use it. We just have to know how to use it. Okay? And class also we can have class abstraction. How class abstraction is work? Okay? Actually we can be as a creator of the class and also we can be a user of the class also, right? Okay? So usually if you see creator, they will be creating the class and they will provide the implementations and everything. But as a user, we don't need to know how it was actually implemented. We just have to know how to use it only. Okay, so this is what we call class abstraction. So the detail of implementation encapsulated and hidden from the user. Okay. But there are so many Java classes and everything, but we are not just know few of it only, right? If you go to Java document, okay, they will have list of all the classes and this class contain what method and everything. Okay, Java document, if you see, they always will have Java documents, okay, which is you can see this class got what method, what parameter, what is the data type, this method, what it will do, everything will be listed there. Okay, so if we just go and refer, oh, this method will do this, but we don't need to know how it is implemented. Okay, it's a class abstraction. Let's see, compute BMI example. This compute BMI example, do you think is a good program? Main method, getting input from the scanner, input the weight, input the height. After that, call a method, which is, the method is here, which is you will compute, pass in the weight and also height. It will identify and return the BMI. So I call the method passing the weight and also height. And what is your BMI? From there I will display whether you are overweight, underweight and everything. Look good? Look good? Yes, look good. Okay. Easy to understand also, right? Okay, easy to understand. Okay. But if you have very complex system and you want to have code reusability and more code reusability and everything, maybe this program is not that suitable. Okay, because this is the way how procedure programming, this is procedure paradigm. The way how we create the program using procedure stuff. Procedure means they will be creating method and data. You see, we will be having a data, we will call that will pass in the data inside. So both are actually separated. Okay. But definitely it works fine and everything. But when the program is get complex and also you want to have easy to maintain and everything, maybe a little difficult. Okay. So this one for small program like this, yes, it's work fine, good, easy to understand. Okay. So if we try to do this one in object-oriented way, let's check. Let's check this one. CD. Okay. So if you want to do object-oriented way, okay, we can do something like this, right? BMI mean maybe I will try to identify what are the data that we want to manipulate. I want to specify who is the person name, let's say. What is his age? Definitely I have to have a weight and also height. So we come out with all the data first. After that, we try to come out with the operation. Okay? We can get the BMI, we can get the status. Okay? These two are tightly coupled. Okay? But previously, if you see, they are loosely coupled. Okay? So we can have constructor, this one also constructor, and we can create the program, right? Okay? So get BMI, I will have the logic how to return the BMI. Okay? So we can program in two different ways, procedures and also object-oriented. The way are actually different. Okay? So even some program is given in procedure program, you know how to convert to OO approach. Okay? Okay, so if you see just now, the value are not tightly coupled, separate variable. But here is when you are creating object, it's tightly coupled. And you also can apply encapsulation, data hiding. We are no need to show the data to the user. We can provide the access modifiers. Okay. This one also access modifier. This one already covered. Okay. Constructor overloading all already covered. Okay. Basically already covered most of it. Everything. Okay. So anyone have any question about any part of chapter 4? Any part of chapter 4? I think there are some questions about many students asking about this question. For assignment, whether you have to create as a role of who is the person who are going to use the system. Correct. Okay. Since this one is a console-based application, or if you go for GUI, it's an application, right? That means desktop-based application. Correct. Okay. So both are application. One is console-based, maybe another one is desktop-based application. You can actually assume you want to do totally everything is done by the admin. Okay, admin. The event organizer means the person, they will have someone who key in the data and everything, right? Admin. So you can assume maybe admin part, maybe they just do maintenance only, scope is a little small, right? You can assume like this, which is you have an office, customer, the participant or anything, they can come and do the registration, they can book for the venue, they can walk in. You use the system to key in for them. Also can. So your registration, booking, or reservation, everything can work also. Okay? So one thing you can assume like that. Another thing is maybe someone they want to do complicated. I want a user or participant to use and so on. Can also you want to combine admin and also the participant or the customer. We can assume like this. My office, I have a kiosk or I have some PCs that they can use. Which is they come, they use the kiosk in order to do the registrations and everything. Can be like that also, right? Because you're not doing a web application, but we can imagine like that. How to differentiate? Admin go and log in with username and password. Customer will log in with the username and password. We can differentiate them, right? Okay? So if your scope is not that big, you want to do the admin and customer part or participant part also can, no problem. We can assume like that. Okay. Any other questions about assignment? Any other questions? No? No? Or any other questions about chapter 4? Chapter 4. Everything need practice and practice. Okay? Yeah? Oh, midterm, midterm. Midterm actually was planned to be on week 9. We have two classes. One is this is the RSW and also RDS. There's another one RSDR, EIR, IIT and everything which is on Thursday. And that week we will have yours not affected because Merdeka, right? Merdeka is Thursday. So yours will be on week 9 Monday. Okay? I'll separate you to two groups. Later, once ready, I'll post it into the classroom. Who will be in the first session and who will be in the next session. Okay? So try to follow that particular session, the timing. Maybe you cannot wake up so early, then you say, I want to come for the second session, then there will be not enough seat because we want to have one gap, one person, like that. Okay? So do